Hi and welcome back. Let's say I gave you an arbitrary element. So let's say I gave you an arbitrary element and we're just going to call it X, and that'll be our chemical symbol. And let's say we had two different isotopes of this element. Let's say we had X that had an atomic mass of 15, and I'm not going to give you the atomic number, so we just have to know that however many protons and neutrons that we had total, that our isotope was going to, the atomic mass of our isotope was going to be 15. And then we also had another isotope of this element X, and this was going to be X19, say. And let's say that the natural abundance of X15 that we found was going to be 25%. And let's say the natural abundance of X19 that we found, and let me choose there we go. The natural abundance of X19 that we found was going to be 75%. So 25% plus 75% gives us 100% of all of the element X that is out there in nature. So now what we are going to try to figure out is what would the actual atomic mass be if we had X as an element on the periodic table. What would our atomic mass be? Well, the atomic mass, you know that the atomic masses that we see, and I'll just scroll down to the periodic table. The atomic masses that we see on the periodic table they're weighted in accordance to the percent abundance that we find the element in nature. So you can think about hydrogen. Hydrogen's atomic mass on the periodic table is 1.0079, but the overwhelming majority of hydrogen atoms out there have an atomic mass of 1. Let's see, there we go. Thought my computer froze there for a second. The overwhelming majority of hydrogen atoms out there have an atomic mass of 1 and also have 1 proton, and that means that they also have 0 neutrons. So the overwhelming majority of hydrogen atoms only have 1 proton. But there are a few different isotopes of hydrogen out there. I think there's hydrogen 2, and I think that there is also hydrogen 3. And I'll check on this. I'm pretty sure that hydrogen 2 is the deuterium isotope, but I forget if it's hydrogen 2 or hydrogen 3. I'm actually not even sure. Hydrogen 3 might not even exist. But anyway, you can see that the way that this atomic mass, this overall number for our atomic mass that's on the periodic table, comes from the fact that the percent abundance of these isotopes in nature, that you have got way more of this in nature than you've got either of these two. So we could make up a number, say that this was like 99.8% abundant, and then this was only, 0.1%, and then this also was only 0.1%. And that's not actually what this is. I'm just making up numbers that could be somewhat plausible for the percent abundance of hydrogen isotopes. So now let's go back to our problem where we had some element X and we had two different isotopes, X15 and X19, and we were going to try to figure out the weighted average of these two different isotopes to figure out what the atomic mass, or really what the molar mass of this element X would be. So how would we go about figuring that out? Well, it would be, we would multiply the mass times the abundance. So we would say that we have the mass of our first isotope is going to be 15, and we know that 25 times out of every 100 times that we find an atom of element X, that it is going to have an atomic mass of 15. And then we could also say that our other isotope of element X, X19, so we could say that our mass is going to be 19, and we would multiply that by the probability that we have of finding an X19 atom, or an X19 isotope. And that means that every 75 times out of 100 times that we find an atom of element X, that it is going to be an X19 isotope. So we can just multiply this out and we would get our weighted average. So let me get out my calculator. There we go. And so we are going to figure out, we are going to say 15 times 25. So let me actually just multiply this all out. So we have 15 times 25, then divide that by 100. So that would be equal to 3.75. And then we're going to add to that, and I'll use my parentheses, 19 times 75 divided by 100, close the parentheses. And so our overall atomic mass that we would write if we were going to write an entry on the periodic table, or the weighted average of all of the atomic masses of this element X, weighted with the percent abundance that we find them in nature, is going to be 18. And I only had 2 significant figures in this, so I'm going to only report it to 2. I should have probably maybe included a few more significant figures. But this is going to be, if we were going to figure out the weighted average of the atomic mass of this element X and the entry that would go on the periodic table, it would be 18. So anyway, thanks so much for watching, and I'll see you in a future video.